Welcome everyone to Chemistry Connections with Mr. Ramsey. Today I'm going to talk about a basic introduction to stoichiometry. Stoichiometry is a process that is an essential skill that chemists must master. Before we get going, I just want to talk about what stoichiometry is not. It is not a research. For example, if I wanted to find the molar mass of sodium chloride, I can look it up on the internet and I can scroll through here and, oh, there it is, 58.44 grams per mole. But I don't know how that number was obtained. So in this video, I'm going to show you how the authors of this webpage were able to determine the molar mass of 58.44 grams per mole. This is an essential skill. The skill is not about being able to do research. It's about being able to follow a process. Another thing that I want you to be aware of is that during an assessment, whether it's formative or summative, you need to be using this periodic table from Fisher Scientific. I have included the link in every single test. If you do not, in every single assessment, if you do not use this periodic table, I'll know because your answers will differ from mine, from the answer key, because different periodic tables have different numbers of decimal places in their answers. And also, if you were to just Google an answer, it would also possibly be different than what we would find using this periodic table from Fisher Scientific. Let's now take a look at some examples. So let's suppose that you're asked to determine the molar mass of sodium chloride, NaCl. There's a few things that we need to be aware of. First of all, there's no subscript written after the Na. A subscript would look like this. Now the subscript 1 is never written. Same thing for the chlorine. There's a subscript there, it's just assumed to be there. So that means that I have 1 mole of sodium, and we can look on our interactive periodic table, find sodium. It's right here. It has a molar mass of 22.99 grams per mole. So I'm going to do times 22.99 grams per mole. And I have 1 mole of chlorine. And we can go to our interactive periodic table. We can find chlorine. It's right here. It has a molar mass of 35.45. Now I need to go to my scientific calculator. I just Googled and clicked on the first one that showed up. So I'm going to type in the 22.99 plus the 35.45. That gives me an answer of 58.44. Whoops. So 1 mole of sodium chloride has a mass of 58.44 grams. And another way to write that would be to say that it's molar mass. So NaCl's, or sodium chloride's molar mass, is 58.44 grams per mole. And if we go back to that original website when I did my search, you see that now you understand how the authors of this webpage were able to calculate the molar mass of sodium chloride. Okay, so here's another example where we have to find the formula mass, which is just another name for the molar mass of calcium phosphate. Now I notice there's a coefficient 3 written in front of the calcium, so there are 3 moles of calcium present. And if we go to our interactive periodic table, we find calcium. It's right here in the second group. It's an alkaline earth metal. It has a molar mass of 40.08 grams per mole. And I'm going to go to my online graphing calculator. I did the calculation out already. 40.08 times 3 gives me 120.24. So I'm going to go ahead and put that here. And now I'm going to look at the PO4. Now, the way that it's written tells me that there are two of these things in the middle of the parentheses. There's 2 phosphorus, and because there'd be a subscript 1 written here, it's assumed. So 2 times 1 is 2. And there's also in 2 PO4s 8 oxygens. 2 times 4 is 8. Okay, so I'm going to write that down. There's 2 times 1 phosphorus. I'm going to put this in parentheses. I'm going to look up the molar mass of phosphorus on my periodic table. 30.97 grams per mole. I'll do 2 times 30.97. Okay, that gives me 61.94. And then we have the 2 times 4 moles of oxygen times the molar mass of oxygen. If you look on the periodic table, there it is, 16.00. And 16 times 8. Okay, that gives me 128. I'm going to put 2 decimal places. Scroll up so everybody can see. And now what I need to do is add these numbers together to get the total molar mass of calcium phosphate. So I'm going to go to my online calculator. I'll do the 128 that's already there, plus 120.24, plus 61.94. Sign. I'm going to copy that so I don't have to keep retyping. An equal sign. And I find the molar mass of calcium phosphate is 310.18 grams per mole. Okay, let's try the next one on your own. And then you can check my video answer and see how you did. All right, here's my solution to this question. So we do not have a subscript written here. Remember, it would be a 1, and there's no subscript here, so it would be a 1. I'm going to type them in there so you can see that. So I have 1 mole of nitrogen times the 2, because I got to distribute this coefficient that's outside the parentheses to each of the this subscript that's outside the parentheses to each of the subscripts inside the parentheses. So 1 mole of nitrogen times 2 times 14.01 grams per mole is 28.02. In the NH4, there's 4 moles of hydrogen here. There's a parentheses with a 2 outside, so I have to distribute that. So times 2 times the molar mass of the hydrogen, 1.008 grams per mole. That's 8.064 grams per mole. There's a coefficient 1 for the carbon. Carbon has a molar mass of 12.01 grams per mole. There's 3 oxygens. The molar mass of oxygen is 16, so that gives me 48. When I add those all together, my calculator gave me an answer of 96.094. Since the 4 is less than 5, I rounded to 96.09 grams per mole. Okay, this is our last example. We're finding the gram formula mass of magnesium sulfate hexahydrate. And you can see the formula Mg, and there's no subscript written here. I'm going to add it in for convenience after the Mg. There's no subscript after the sulfur, so I'm going to add it in for my own convenience. There's 4 oxygens here, the subscript 4. And then I have this big number. This big number is called a coefficient. I'm going to distribute this coefficient to the subscripts. So since I have 2 hydrogens, a subscript 2 here, I'm going to do 6 times 2. And then I do not have a subscript after the oxygen. Remember, I'm going to add it in. The subscript 1 is never written. So I'm going to do 6 times 1. So I found the molar mass of magnesium to be 24.31. Multiplied that by the 1 because of the subscript 1 here. I have 1 mole of sulfur because of the subscript here, multiplied by the molar mass of sulfur, 32.07. I'm getting these numbers, remember, from the periodic table. For the oxygen, I did 1 mole of oxygen times 4, because there's a subscript 4, times the molar mass of oxygen, which is 16. And then for the subscript here is a 2, so 2 moles of hydrogen times the 6 because of the coefficient here, times the molar mass of oxygen, hydrogen, and then 1 mole of oxygen times 6. Remember, I have to distribute this coefficient 6 to all of the subscripts shown here in the H2O. When I added those all together, I got 212.48 grams per mole. I hope this has been helpful, and if you have any other questions, let me know.